Welcome to the lecture on linear functions. In this lecture we're going to review a little bit about lines, but we're going to talk about them in the context of functions. So if you can visualize what the graph of a line would look like, then you can think about the vertical line test, and you should be able to see that every line is a function except for vertical lines. So for example, if we have the line y equals 2x plus 1, that's a line with a y-intercept of 1 and a slope of 2, so up 2 over 1. So it would have a shape like this. And obviously that's going to pass the vertical line test because every vertical line is only going to intersect it once. So every line that's slanted like this is going to be a function. If we think about a horizontal line, which would be an equation of the form y equals a number, y equals 3, has a graph that looks like this, nice horizontal line. That also is going to pass the vertical line test. However, if we have an equation of the form x equals a number, that's a vertical line, so x equals -1 would be a vertical line like this, and obviously that's going to fail the vertical line test when you look at the vertical line right through -1. So this is the only one that is not a function. Okay, so let's remember a couple of things here. If we think about equations of lines, there's a special form called the slope-intercept form, y equals mx plus b. We can easily turn that into function form by just swapping out this y with f of x. And so now we rewrite it almost identically, but now it's f of x equals mx plus b instead of y equals mx plus b. So remember, when you're talking about functions, f of x and y are synonymous with each other. So f of x always is the same thing as y. So when the question might say graph the function f of x equals -3x plus 4, if it helps you, you can swap that y right back in again. So we're going to put y right where this f of x is and rewrite it in a form that you're probably more familiar with. So y equals -3x plus 4 is a line that has a y-intercept of 4, so it's going to go right through the y-axis at 4, and the slope is this -3, and if I rewrite that as -3 over 1, then I have a rise, or actually in this case a fall because it's negative, of 3. So I'm going to go down 3 and a run of 1. So I'm going to go over 1. And that would be my line, and that would be the graph of this function. Now let's talk about the equation of the line with slope -2 and y-intercept 0, 5. Put the line in function form. So this one is kind of nice because we're told what the slope is, and that's typically our m number, and we're also told our y-intercept, which is typically called b. So in this case our b is 5. So this is perfect because we have this slope-intercept form called y equals mx plus b. So to write the equation of the line, all I have to do is substitute in -2 for the m and +5 for the b, and there's my line. The only problem is it's not in function form. So all I have to do to put it in function form is swap out the y with f of x, and then I have my function. So f of x equals -2x plus 5. Alright, let's do a more traditional problem. Find the equation of the line in function form that goes through the 2 points 1, -2 and 2, -3. So we've done this kind of problem before. To find the equation of a line between 2 points, you always have to find the slope first. And if you remember that to find slope, that's change in y over change in x, or y2 minus y1 over x2 minus x1. So all I have to do is take my two y values and subtract them. I'll start with this -2 and subtract the -3. Since I started with the -2 on top, I need to start with the 1 on the bottom. So 1 minus 2 on the bottom. Now you do get a double negative on top. So -2 plus 3 is 1, and 1 minus 2 is -1. So when I reduce that, that makes my slope -1. Now, unfortunately, neither one of these 2 points that I was given is a b, because in order to be a b, you have to be a y-intercept, which means your x value has to be 0. And neither of these 2 points has an x value that's 0. So what I'm going to use next is something called point-slope form, another special form that's good to know when you're writing equations of lines. And this form said y minus y1 equals m parentheses x minus x1. So that's what I'm going to use. I'm going to leave the y as y, and I'm going to substitute in for y sub 1 the y coordinate of my point. And it doesn't matter which point we use here. Let's go ahead and use this second point, 2 comma negative 3. And we just found that our slope m was negative 1. So this is my point, and this is my slope. So the y value of this point is negative 3. That's going to go right here, and you will get a double negative. My m is negative 1, and my x value was 2. So now all I have to do is clean this up a little bit. So first of all, I've got a double negative. Let's make that plus, and let's go ahead and distribute our negative 1 across. So negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. And let's go ahead and solve this for y. So I'm going to subtract 3. So y equals negative x minus 1. So to finish off the problem, we just want to make sure that we read the original problem and make sure we're answering the question that's being asked. It wanted to find the equation of the line in function form. And remember that function form is exactly the same thing as slope-intercept form, which is exactly what we have already. The only difference is that the y gets replaced with function form, which is f of x. So all we have to do is swap out our y, change it to an f of x, and then recopy our equation, negative x minus 1. So our final answer is f of x equals negative x minus 1. Alright, let's try another problem. This one says, find the equation of the line in function form that has an x-intercept of 4 and a y-intercept of negative 3. So you want to be careful on this one. We have an x-intercept of 4. What does that really mean? If you're an x-intercept, that means you're crossing the x-axis. What do we know about a point that crosses the x-axis? We know that its y value has to be 0. So when they say that you have an x-intercept of 4, that really means this must be the point 4, 0. Similarly, if you're a y-intercept, you're crossing the y-axis, then your x value has to be 0. So this must be the point 0, negative 3. Now we also know y-intercept, sometimes we call that b. So this point, negative 3, also happens to be the value of b as well, which is good to know because if we know b, then we can use y equals mx plus b to figure out our line. If we know b, we've got that part of it, we still need to know the m first. So that's our next goal here, is to find the slope m. And we're going to do that again by doing y2 minus y1 over x2 minus x1. So let's start with this y value 0 first, and I'm going to subtract this y value negative 3, so you get a double negative. And then I'm going to subtract the 4 minus the 0. So minus minus becomes plus, so this is 3 over 4. So my slope m is 3/4. Now remember what we said, y-intercept is also called b, so we also know the value of b. So if I have m and b, then I can use y equals mx plus b and substitute in. So we get y equals 3/4 x, and b was negative 3, so this is going to be minus 3. And last but not least, we want this in function form, so swap out the y with an f of x, and here's our line, and we're all done. Okay, next one. Find the equation of the line perpendicular to the y-axis that goes through 3, negative 1. So what I would recommend on this is visualizing what kind of line we're talking about. Here's our axes, and we want to be perpendicular to the y-axis. So the y-axis is actually a vertical line. So if we want to be perpendicular to it, then we would have to go horizontally. So we're looking for some kind of horizontal line. Now, what do you know about horizontal lines, or what should you have memorized? Every horizontal line is always of the form y equals to a number, y equals to a constant. So if I know that I want this line to go through 3, -1, what does the y have to be? It has to be the y value of that point. So this one doesn't really have much work to do for it. All we have to know is that we want y equals, and then we need to know that we should use the y value of the point. So the equation of this horizontal line that we're looking for is just y equals -1. I didn't have to calculate any slope. I didn't have to do any point slope form or anything crazy like that. It's just memorizing the fact that horizontal lines are y equals to a constant. Okay, the next example. Find the equation of the line containing 8, -3 that is parallel to the line 3x plus 4y equals to 1. Write the equation in standard form. So we'll worry about the form later. Let's first find the equation of the line. So if we want to find the equation of a line going through a point that is parallel to another line, that means we want our two lines to be parallel, which means their two slopes must be equal. Parallel lines have equal slopes. So if we want to be parallel to 3x plus 4y equals to 1, to find the slope of the line I want, I'm going to need to find the slope of this line and use the same slope so that my slopes are equal. So step 1 here should be to find the slope of this line. Now, how do you find the slope of a line given its equation? You have to put it into y equals mx plus b form so you can find that m. That means solving this for y. So the first thing we're going to want to do is subtract 3x from both sides. Try to get that y term by itself. And then I'm going to divide every term by 4 and reduce. So I get y equals 1/4 minus 3/4. Now let's just push that x to the side. So from this equation, which of these numbers here is your m? Remember that m should be the coefficient of x, and that includes any signs in front of it. So the slope of this line must be -3/4. That means the slope of our parallel line, and this is the little symbol here for parallel, must be the exact same slope because parallel lines have equal slopes. So the slope of our line needs to be -3/4 as well. What else do we know about our line? We know that our line has to go through 8, -3. So look at what we have. We have a point and we have a slope. So if we have a point and a slope, we're going to use point slope form. That's the one that said y minus the y value, and here the y value of my point is -3, equals the slope m, which we just found out was -3/4, parentheses, x minus the x value, and the x value here is 8. Now we need to clean this up. So we have a double negative, it's going to become y plus 3, and we need to distribute our -3/4 across. So -3/4 times x, a negative times a negative is a positive, and just a little scratch work here, -3/4 times -8, 4 goes into 8 twice, so we're left with 3 times 2 or 6, all over 1, which is just 6. So this is going to be a positive 6. You can use your calculator on that as well. To finish it up, let's subtract the 3 to the other side. So we get y equals -3/4 x plus 3. Now we want to worry about what form we're supposed to put this in. So we want to put this in standard form, and that, if you remember, is kind of our special form, our form that's pretty. So standard form is our pretty form, which is this form that looks like ax plus by equals to c. And what that means is we need to get the x and the y terms on the same side of the equation. So that's one thing that I'm going to need to do here right away. So to move this x term over to here, we're going to need to add 3/4 x to both sides. So this becomes 3/4 x plus that y equals to 3. Now the other part of this that makes it pretty is that the a, the b, and the c are not allowed to be fractions. So we want to clear out any fractions that we have. And the only fraction I have is 3/4, so to clear it out I need to get rid of its denominator, and we can easily do that by multiplying by the denominator. So I'm going to multiply every single term by 4 to keep the equation balanced. 4 times 3/4 cancels out the 4, so this is just 3x. 4 times y is 4y, and 4 times 3 is 12. So this is the equation of our line in standard form. Now we're going to do almost the identical problem. We're going to find the equation of the line going through 8, -3, but this time we want to be perpendicular to the given line 3x plus 4y equals 1. So what's going to change up here? If you want to be perpendicular to another line, what do you know about the slopes of perpendicular lines? You should remember that the slopes of perpendicular lines are what we call opposite reciprocals. So they're opposite signs and they're flipped over. So if you remember from up here, we had a slope of -3/4 from the given line. So let's write that down. The slope from this line turned out to be -3/4 when we solved it for y. So what should be the slope of our perpendicular line? And this is the little symbol for perpendicular, an upside down T. Well, we need the opposite reciprocal number. So if we make it opposite, it's going to turn plus, and if we do its reciprocal and flip it over, this becomes 4/3. So that's the new slope that we want to use. And we still want to go through 8, -3. Now remember when we solved up here and we simplified this, we got y equals -3/4 x plus 3. Sometimes students, when they do a problem like this, they think, oh, well, all I had to do was flip the slope over and change its sign. So can't I just change this -3/4 and turn it into a 4/3 and be done? Unfortunately, no, because when we use the slope 4/3, not only does it change this m number, it's also going to affect and change this b. So your equation is not going to look anything like this one right here. So we have to rework through that point slope form to figure out what the new equation should be. So let's do point slope form again. We want y minus the y value, which was -3, equals our slope, and now we're going to use 4/3, parentheses x minus the x value 8. And now we're going to clean it up, plus plus, so this becomes y plus 3. And if I distribute the 4/3 across, I get 4/3 times x minus 4/3 times 8, or 8/1. Nothing in the denominator reduces into anything in the numerator. So I'm just going to do top times top over bottom times bottom. So that's 32/3. And then to finish it off, I'm going to subtract 3. So we get y equals 4/3 x minus, now 32/3 is a fraction with a denominator of 3. 3 is a whole number with a denominator of 1. So in order to add these, we need a common denominator. So I'm going to use the denominator 3, and 3 is the same as 9/3. So 32 and 9 is 41. So this will be -41/3. You can use a calculator on that as well. So we have our line. Let's find out what form we want it in. This time we want it in function form. So to finish it off, I just swap out my y with an f of x, and this becomes f of x equals 4/3 x minus 41/3. And it's okay to have the fractions because this wasn't asking for that pretty form, that standard form. So we can leave those fractions as is. Okay, let's talk about some domain and range here. if we have the function f of x equals negative 3x plus 2, what's the domain and range of that function? What you need to be thinking about is the graph or the shape of this function. And hopefully you recognize that this is a linear function because it has that x to the first power. And we should be able to graph this fairly easily. It's in that nice slope-intercept form. The b here is the plus 2, so we have a y-intercept of 2. And our slope is negative 3, or negative 3 over 1. So that means we're going to go down 3, 1, 2, 3, and over 1. So the graph of this function looks just like that. So based on that, what's the domain and what's the range? Now remember, domain is x's. So when you're thinking about domain, you want to think how far to the left does this go and how far to the right does this go. And because of these arrows, this line continues to go all the way left and it continues to go all the way right. So every x value gets used. So the domain of this line is all real numbers. Now let's find the range. The range, you want to look up and down. So how far low do I go and how far up do I go? And again, because of those arrows, we continue to go down and we continue to go up. So the range here is all real numbers as well. So for a linear function, your domain and your range are all reals. Alright, let's take a look at this graph below. So this is the graph of f of x. We're not told what its equation is, and we just want to answer some questions about it. So first thing I want to know is, what is f of 0? Now you need to remember your function notation here. The number inside of the parentheses, that's your x, or your input. So when it asks for f of 0, it's asking for what's the y that goes with an x value of 0. So we need to look at this graph and find which point on this graph has an x coordinate of 0. And hopefully you can see it's right there at the origin. So that's the point 0, 0. So when x is 0, y is 0. So that means f of 0 equals 0. Now we're going to do that again, but this time we want our x to be 2. So we're looking for where is x 2 on this graph. So you go over to 2 on the x-axis and find the dot on the curve that has an x value of 2. And what are the coordinates of that point? That's 2, 2. So when x is 2, y is 2. And that's your function value. Okay, and now we're going to do it one last time. We want to find out what happens when x is negative 4. So I'm going to go over to negative 4, go up to my graph, and find out what the y value is there. This is the point negative 4 for x and positive 4 for y. So the y value is 4. So whenever it's asking for f of something, it's asking for the y value. Now let's find the domain. So remember, domain is x's. How far to the right and how far to the left does this graph go? And because of these arrows, it's going all the way to the right and all the way to the left, and I didn't skip over anything in between. So my domain is all reals. Now how about the range? For the range is y's. So you want to think, how high and how low does this graph go? Now you can see from the arrows that it is going all the way up, 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 and it doesn't stop. But there is a low point on the graph that it doesn't go below. It doesn't go any lower than that origin. So what that means is my range starts at 0 and it goes up from there. And remember, you always put parentheses around infinities. But what about the 0? Does it actually hit 0? Yes, there was a dot right at 0. So your range here is 0 to infinity. Now the last question here is to find all the x values such that the f of x is equal to 1. So here again, notation, we need to be a little bit careful. Remember, f of x is the same thing as y. You can swap it out with a y. So this is basically asking, what is x when y is 1? So it's kind of the opposite of the ones we did earlier when we were given x and we were looking for y. Now we know y and we want to figure out x. So let's locate all the points where the y coordinate is 1. And the way I like to do that is think about y equals 1. If you were to graph y equals 1, what kind of line is that? That's a horizontal line because it's y equals a number. So let's draw a horizontal line at a height of 1, and any place where that horizontal line intersects my graph, which would be right here and right here, those are the points on the original graph that have y values of 1. This point right here is negative 1, 1, and this point right here is positive 1, 1. So what are the x values when y was 1? Well, either x was negative 1 or positive 1. Okay, the last couple of problems here are just a couple of word problems. So the next one here says the annual average income of an American woman with a bachelor's degree is given by this function, where x is the number of years after 1999. So 1999 is kind of our base year. So the first question is, find the average income of an American woman with a bachelor's degree in 2000. So if we want to know what's happening in the year 2000, what does that mean? Remember that x was the number of years after 1991. So the year 2000 is 1 year later than 1991. So that would imply that we want to look at what happens when x is 1. When x is 0, that's 1999. So x equals 1 should be the year 2000. So all we have to do for part A is find out what the value of this function is when x is 1. So what we're really looking for is f of 1. So we're going to plug in 1 for x. And these numbers are pretty yucky, so you definitely will want a calculator. We move this over a little bit. So we want 4174.9 times 1 plus 42173, and we get 46347.9. 46347.9. I don't know if I remembered that correctly. 46347.9. Yes. Now, what about some units on this? What does this value represent? It's the f of x value, which is that annual average income. So this is a money value. So I'm going to put a comma in here and a dollar sign on there. So this means that the average income is $46,000 and change in the year 2000. That's what we just found. Okay, so now part B, find and interpret the slope of this function. So first of all, here's my function up here. Which of these two numbers represents the slope? This is just in that nice perfect form mx plus b. You've got mx plus b up here. So it's really obvious what your slope m should be. It should just be that coefficient of x. So my slope is this 4174.9 number. Now that's finding it, but we need to interpret it as well, which means to find its units. Now how do you find slope? How do we normally find slope? We usually find it by doing change in y over change in x, subtracting the y's and subtracting the x's. So when I like to interpret a slope, I like to think about what the units should be for the y's and the x's, and that will help determine what this slope means. So what do these y values represent, and what do these x values represent? Let's start with the easier one. The x values, remember up here it said x is the number of years, so x is just years. What did the y represent? Remember the y were these incomes, these dollar values. So this is the dollar in income. So what I like to do to interpret my slope is I take this m number and I'm going to put some units on it. The top is that dollar income, and this is over years. And if you put a 1 in here on the bottom, that can help you figure out how to interpret this. I'm just going to kind of say it out loud. This means that the dollar value in the income goes up, and I'm saying up because it's positive, $4,174.90 per year. So think of that fraction line as per. So the slope means that the average annual income rises or goes up by $4,174.90 per year. Okay? So that was our M. The next question says, find and interpret the y-intercept of the function. Y-intercept, we know that as b. So which of these numbers up here was our b? That's that constant on the end. So b is 42,173. And what does that represent? Well, if you're a y-intercept occurs when the x value is 0. And in the context of this question, what did it mean when x was 0? Well, when x was 0, that was the year 1999. And what did this y represent? What do y values represent? Remember, we set it up here. Y was your income, dollar values. So this b is a y value, so I'm going to put a dollar sign on it, and it represents the income in year 0, which in this case was 1999. So the average annual income of an American woman with a bachelor's degree in 1999 was $42,173. Okay, last question. The number of people employed in the U.S. as registered nurses was 2,284,000 in 2002. By 2012, this number is expected to rise to 2,908,000. Let n of t, so that's function notation, let n of t be the number of registered nurses, in thousands, employed in the U.S. in the year t, where t is 0 represents 2002. So again, we're going to use a base year here to make our numbers a little bit easier. Part A, write a linear function that models the number of people, in thousands, employed as registered nurses in the year t. So the keyword here is write a linear function. So in other words, we're trying to find the equation of the line that models this problem. Now, in order to do that, I would recommend that you convert this paragraph or these paragraphs into two ordered pairs, two numbers that you know go together. And we're going to use those two ordered pairs to come up with the equation of our line. So the first ordered pair that I'm going to use is the first set of data that they tell me, 2,284,000 in the year 2002. Now, what should I put first? Should I put the year first, or should I put the number of nurses first? It kind of could be either way, but in this problem, they tell us to let t be the years, and t is this input inside of those parentheses. So typically, we're going to put time first. So I want to put the year first, but I don't actually, in this problem, want to use 2002. That's where this base year comes in. To help the numbers be a little bit nicer, instead of writing 2002 here, I'm going to write just 0. And know that in the back of my head, 0 represents 2002. So in that base year, when t was 0, what was the number of nurses I had? 2,284,000. Now again, here you have a choice. You could add in 3 more zeros to represent the fact that this was 1,000, but it's telling you in the problem to assume that this is in thousands, so we're going to leave off those zeros again just to make our numbers a little bit cleaner and a little bit easier to work with. So there's our first ordered pair. In the base year 0, we had 2,284,000 nurses. What's the other ordered pair that we know? Well, we know that in 2012, the number rose to 2908. So we know that this new y value is going to be 2908. And in 2012, how many years later than our base year is that? Since our base year was 2002, well, 2012 is 10 years later. So I want to use a t value here of 10. So here are my two ordered pairs. And now basically all we're going to do is find the equation of the line between these 2 points. And we've already done that earlier today. So first thing we have to do, always the most important thing about a line, is its slope. So let's find its slope first by doing y2 minus y1 over x2 minus x1. So this is going to be 2908 minus 2284 all over 10 minus 0. So we're going to pull up that calculator again, and we want 2908 minus 2284. So the numerator is 624, and then we're going to divide that by the 10 that's in the bottom. So 62.4. So this was 624 over 10, which became 62.4. So there's my m. So I have my m. Now you have two choices here. You could use point slope form, or if you notice, and you're a little bit lucky in this problem, this is a b. This is a y-intercept right here because the x value is already 0. So I'm going to make use of that, and I'm going to realize that I can just jump directly to that slope-intercept form, y equals mx plus b, and I'm going to plug in my m that I just found, 62.4, and my b is this 2284. Now last but not least, this is the equation of my line in terms of x's and y's. But remember, they wanted us to write it in a function notation, and they actually gave us specific numbers and letters to use. They wanted us to use n of t, where t is the number of years. So in our problem, remember these x values here, those were our years. Instead of calling them x's, they want us to call them t's. So we're going to change this x to a t. And normally when we write things as functions, we swap out y with an f of x. This time they don't want us to use f of x, they want us to use n of t. So I'm just going to swap out that y with n of t. So here's my linear function that will predict the number of registered nurses in any year after 2002. Okay, the last part of the question. Use this model to estimate the number of people who will be employed as registered nurses in 2010. So this is important that you remember we have that base year again. So the base year was 2002, so 2010 minus that base year means we're talking about 8 years later. And that means we want to use an input of 8 for our time t. We don't want to use 2010, we want to use 8. And I'm going to take that 8 and I'm going to substitute it in for my time. So we're just going to use this model that we just came up with and predict the number of nurses in 8 years. So that's going to be 62.4 times 8 plus 2284. And let's pull out our calculator again. We want 62.4 times 8 plus 2284. And this is the number of nurses that we're figuring out here. This is an actual number of people. So I'm going to round this off because we don't want a fraction of a person. So 2,783 nurses in the year 2010. And there's our estimate. Okay, that concludes our lecture on linear functions. Good luck.